Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Una Isla de Pairrows by AQJHS. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have Nurikabe, where we need to shade some cells such that all shaded cells are orthogonally connected and no 2x2 area is fully shaded. Cells marked with circles can be either shaded or unshaded. So, what's a valid Nurikabe? So all these shaded cells must be shaded, and there can't be a fully unshaded 2x2 area that is fully shaded. So this could be a valid Nurikabe. What does it mean for all shaded cells to be orthogonally connected? It means you can go from any shaded cell to any other shaded cell just by going through edges, all while staying within the shaded region. So you could have something like this too. You could have something like this. This is a valid Nurikabe because you can go from any shaded cell to any other shaded cell just by going through edges. This would not be valid because this cell, you cannot get to that cell from any, you can't go from that cell to any of the other shaded cells by just going through edges or while staying within the shaded region. You would have to go outside the region or go through a corner. We do not have the same constraint, though, for the unshaded cells. Unshaded cells, you can have multiple, in fact, you almost certainly have multiple aspects of it in Nurikabe. If you don't have multiple sets of unshaded cells, then it's basically yin-yang, which is basically a more restricted version of Nurikabe. And also in this puzzle, there is no 2x2 area is fully shaded, but that restriction is not in place for the unshaded cells. And again, cells marked with a circle can either be shaded or unshaded. So that is the gist of Nurikabe. A shaded cell with a circle has a digit equal to the count of shaded cells seen in its row and column, including itself. Unshaded cells block sight. So this is a shaded cell with a circle in it, and it counts how many cells it sees horizontally and vertically, including itself, that are shaded. So this would be 7 in that case, because unshaded cells block sight. So these does not see any of these shaded cells here. So this would be 7, but then we have a problem here because this would also see 7 because it cannot see these shaded cells here because we have an unshaded cell blocking view. So that would be 7, that would be 7. This would see 2 because it just sees those 2. This would see 8 because it would see all 8 here. This would see 11, but that's obviously not valid because it must be a digit from 1 through 9. But those are examples of how shaded cells with a circle work. Each orthogonally connected group of unshaded cells contains exactly one circle, and the digit on it is the number of cells in that group. So this is orthogonally connected group of unshaded cells because you can go from any cell in that group to any other cell in that group just by going through edges, all while staying within the region, within the group. So this would be size 6. But the thing is, there's only one circle, so that's an issue with this. But these would be 6 and 6. This, again, you can't have circles. You can't have more than one circle in the unshaded cells, but this would be a really large number because this is a very large unshaded group a group of unshaded orthogonally connected cells. This would be 3 here if that were the case. So that is how circles in unshaded cells work. And remember, you can only have one in the group, one per group for the circle. So this is obviously not a valid. This is not a valid Nurikabe in the sense that we have to break up these circles from each other. They either have to be in a shaded cell, or you can only have one circle in a group of unshaded cells. Oh, and each group of unshaded cells contains exactly one circle. So that means you can't have 0 circles in that in any unshaded group of orthogonally connected cells. Interesting. We have a pairrow where it's a pair of arrows on a cell with a digit D points to 2 cells D steps away in the direction of the arrows, and depending if the cell is shaded or not, the digits on those cells follow the corresponding rule. Obviously, this is going to be problematic because this can't get to 7. This can't get to 8. Let's use 3 and 2. So this is 3 here. If the pairrow cell is shaded, the difference of the digits is 2. So this is saying that the cells 2 steps away, which would be 1, 2, and 1, 2, have to have a difference of 2. So you could have something like 9 here and 7 here. That would be valid. Or 4 here, 2 here. That would also be valid. Because the difference between those 2 cells must be 2, and they're 2 cells away from both of these cells. If a pairrow cell is unshaded, the sum of the digits is equal to D. So this is 3 steps away, so this must be 3 steps away, and that must be 3 steps away. So these must add up to 3, if that's 3 steps of cells away, and they're unshaded. So therefore, this could be 2 and 1 here, or obviously 2 and 1 there. And that would fulfill this pairrow. Because since this is unshaded, these 2 digits must add to 3. If the pairrow cell is shaded, the difference must be D. And if the pairrow cell is unshaded, the sum of the digits must be equal to D. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Easiest steps are looking at the pairrows and seeing how long they can go. So, this can go 1 or 2. And this can go 1 or 2 here, right? This can go 1 or 2. So this is 1 or 2, this is 1 or 2. This can go up to 3. 1 through 3. This can go up to 3. This can go up to 3 cells away. These cannot be 1 or 2 because of the 1, 2 pair in the box. And same with these, it can't be 1 or 2. This can go 1, 2, 3 away, so this is 3. This can go only 4 away, so this is 4. So 4 away marks this and this. If they were sums adding up to 4, it would have to be 1 and 3, which would eliminate too many possibilities here. That would force this to be 2 and 2, which you can't have a duplicate in a row. So this must be shaded then, because the sum cannot add up to 4 here. Can the sum here add up to 3? So far, yes. You can do 1, 2, 1, 2. So this is 4 and is shaded. We don't know about this. Remaining digits here. So this C's can be 1, 2, 3, 4, 5, 6. So this is up to 6. So this is 3 through 6 here. This C's up to 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, 8. No, this is 7 here. Sorry. 1, 2, 3, 4, 5, 6, 7. So this is 3 through 7 here. This can be 1, 2, 3, 4, 5. So this is 1 through 5 there. This C's 6 at most. So this is 1 through 6 here. This sees 6 at most this way, so this is 1 through 6. This sees 7 that way or 7 that way, so this is 1 through 7. Remaining digits of row 7 have to be 5 through 9. Remaining digits of column 2, so this has to be, sees 1, 2, 3, 4, 5 at most. Cannot be 1 or 2 because of the 1, 2 pair in the column. So this is 3, 4, 5. Remaining digits in column 2 are 3 through 9. Okay. Same with box 7. Okay, it's pretty restrictive. So these are 1 or 2 in size. They cannot be the sum of any digits. So they have to be shaded. So these are all shaded. This sees then 2 shaded cells because it's a circle and it must only see 2 shaded cells. So this is 2, this is 1, which makes this 2. This can no longer be 2 here, or here, or here. So these must be unshaded. And we'll mark those as green. So this has to be a sum of digits that add up to 3, which is 1 and 2. So this is a 1, 2 pair. Here and here, which eliminates 1 and 2 in the rest of the row. This can't be 1 or 2, it's 3. This can't be 1 because this cannot be the sum of 2 unique digits adding up to 1. So this has to be 4, 5 here. Therefore, these can't be 3 because of 3 in the column. 3 eliminates 3 here, so it's 4 or 5. 3 away and 3 away cannot be a sum because this is at greater than 3. So this has to be shaded. This sees 2 shaded cells. This must connect orthogonally shaded. So this is 1 and 1, which means the difference between them is 1. The difference between these are 2. The difference between this and this is 3. Difference between these are 4. These cannot be the same region, so this has to be blue. Right, if it's green, these are part of the same region, and this region would have 2 circles. So this is blue. We have a 4, 5, 4, 5 pair in box 4, which eliminates 4 and 5 in the rest of the box. So this can't be 3, 4, 5 because of the 3 in the box. Remaining digits of row 4 are 4 through 9. No 2 here because of 2 in the row. This must sum up to 4 or 5. If it's 4 away, we have 1, 2, 3, 4, and 4. This would have to be a 1, 3 pair, which would make that 1 and that 3. If it's 5, So either this is 1 and this is 3, or we have it adding up to 5. This cannot be 2 or 3, so this would be 1 or 4, and then this would be 1 or 4 there. If we have 1 here, obviously this can't be 1. If we have 3 here, then this would have to be 2 digits adding up to 3. Well, actually, no, it could be difference. Never mind. We only know that because these are shaded cells. So this cannot be part of that. And this is necessarily going to have to go here or here. So this must be shaded. And it's C, 6 through 9. That's interesting. Remaining digits in box 4 are 1, 2, 6, 7, 8, 9. And this can't be 2, obviously, because of 2 in the column. Four away could... This sees 4 cells because it's a circle in it. This has 3, so it must go here. And therefore, this is now an island. So these must be blue. So since this is blue, this sees 4, 5, or 6. That's this island of 3. This is 4 or 5. We don't know if it goes this way or that way. Hmm. This sees 3. Hmm. 3 away from this. Remaining digits of column 3 are 1, 4, 5, 6, 7, 8, and 9. So the difference between this and this is 3. So 1 can never be here, because the difference between 1 and 5, 6, 7, 8, or 9 is not going to be 3. You could have 4 and 7 here, 5 and 8, 5 and 8, 6 and 9, 6 and 9. This can't be 7. Because if that's... So one of these... So either this is 1 and that's 3, or this is 1 and that's 4. Okay, that's not helpful. And that's basically looking at this, right? Oh, wait. This is... So either this is 4, which makes this 1 and 3, or this is 5, which makes this 1 and 4, adding up to... So either way, there's a 4 here or a 4 here, which eliminates 4 in the rest of the column. So this can't be 4, this can't be 4, this is 5 or 6 away. So 5 away would be 1, 2, 3, 4, 5. And that would have to have a difference of 5 with that, so this would be 8. So you either have that 8 and this is 3, or you have this is 6 away. And obviously this could not... So if this is 5, this is 4. If this is 5, that's 4, which makes this 1 and 3, which would make that 6. Or this is 6. This 5 cannot be 6 away from another digit, so that would be 1. Huh. This must see at least 5. So then it has to go to here as blue. This sees 3 here, so only one more of these in one of these two spots. So one of these is green, one of these is blue. Okay. Because this sees 4 cells. No 4 there. Okay, so again, if this is 5, that means this is 3 and 8. This is 4, which makes this 1, that's 6. Okay. 1, 2, 3, 4, 5, 6. So therefore, this would have to be... There's no difference of 5 and 6. So that would be unshaded then. And then this would be 1 in that instance. Huh. That's interesting. Otherwise, this is 6, which means this has to be 1, and that's 7. To have a difference of 6. This would be 1. So that means there would have to be a difference here. So, okay, let's go through. If this is 6, that means this is a difference of 6 between these digits. So it must be 1 and 7. That means this cannot be 1 and 3, which means this must be 4 and 1, which makes this 5. But then the problem is, this has to have a difference of 1 between these two digits. 5 eliminates 5 here, so that's 4. Which means this can't be 4 either, can't be 1 or 2, and we have a contradiction. So therefore, we know this cannot be 6, this must be 5, which makes that 4, which makes that 5. 5 away has a difference between these. So this cannot be difference of 5. This is 8, which eliminates 8 in the rest of the row, and 5. No 5 and 8. This is 4. This can't be 4 or 5. There's no 4 here or 5. No 5 here. This then cannot... This is 4 away, adding up to 4. So it has to be 1 here and 3 here. That means this can't be 1, it's 6. No 1 or 6 here, no 6 here, no 6 here. So this is a 6. This cannot have a difference of 6 between 5 and another digit, so this must be the sum, which means this is green. So this has to be 1 here, which means this can't be 1. There's no 1 here, there's no 4 here, no 6 or 5 here, no 5 here. Okay, so this is size 4, this is size 6. 1, 2, 3, 4, 5 could be a sum. The difference between these two is 1. Difference between these two is 2. So this cannot be 3 or 4. It has to have a difference of 1 here. This can't be... These two away has a difference of 2 with this. So this is either 3 or 7 there. 3 away is 1 and 2, 1 and 2. 4 away, 1, 2, 3, 4. 1, 2, 3, 4 is 1 and 3. 3 away, you could have 2 here and 1 here. So we don't know if this is shaded or unshaded. 6 is the sum of 5 and 1. If this were to go 4 here, then this would be shaded, but then this doesn't have unshaded cells that have a circle related to it. So 4 cannot go this way because that forces this to be shaded, and therefore these can't match with a circle. So say this was shaded, then this can never be shaded then. If this is shaded, we'd have a 2x2 box that's all shaded. Because these can't be connected to a circle, which every unshaded group of orthogonal connected cells has. So therefore, this cannot be shaded. This is unshaded here. So this must be the sum. So 3 away could be 1 and 2 to add it together. That could work. This is at least 3 in size, so it's 1, 2, and 3. That's possible. 5 away is 1, 2, 3, 4, 5. So we're definitely having that. So if it's a sum, it has to be 1 and 4. Because it cannot be 2 and 3 because of the 3 in the column. If it's a difference, it's 1 and 6 or 2 and 7. So we don't know which one that is. These add up to 1 and 2 or 3. 4 away has a difference. So this is 5, so this cannot be 7. So we don't know what that is. Remaining digits of box 1. Oh, this can't be 5 because of 5 in the box. So remaining digits in box 1 are 3, 4, 5, 7, 8, 9. Obviously no 3s here because of 3s in the row. So either this is the sum of 2 digits adding up to 3, which would force this to be 2 here and 1 here, or there's a difference of 3. 2 can go with 5, 4 can go with 1 or 7, 5 can go with 2, no 8 here because of 8 in the box. 6 can go with 9, cannot be 3 here because of 3 in the box. 7 can go with 4, 8 can go with 5, and 9 can go with 6. And those are the possibilities, which is basically everything there and everything there. That wasn't helpful. This has a difference of 2. So we know none of these can be 1, I guess, because 1 can only be 2 away from 5. Or sorry, 3. 2 away from 3. So 2, 4, 5, 6, 7, 8, and 9. That's pretty broad. 3 away for this one. 8 would have to be with 5, and 9 would have to be with 6. Okay. 5, we did all of those. You could have 3 green here. Hmm. Oh. Hmm. This sees 5. Could be all 5 that way. Hmm. Could be 5 that way. Could be 5 that way. This is likely a green. If this were 3... Okay, so if this is 3, you can't have 2 digits here adding up to 3 because we have a 1 in the column. So this has to be, if this is 3, it has to be shaded. If it's 1, it has to be shaded because 1 obviously can't have 2 unique digits adding up to 1. So this is shaded either way. Therefore, you can't have 1 in a shaded cell. It has to be orthogonally connected to the rest of the cells. So this is 3, which means this can't be 3. This has to be shaded. You can't have 3 in a circle, I should say, in a shaded cell, right? Because that's saying I only see one cell, which would be itself, but it has to orthogonally connect to the rest of the shaded cells, right? So this is a difference of 3, which means this can't be 3 here. These have to have a difference of 3 here. This can be 4, 5, 7, 8, 9. 4 can be 3 away from 7. 7 can only be 4 away from 4, but this can't be 4 because of 4 in the row. 5 can be 3 away. I kept saying 4 away. 4 can be 3 away from 7. 5 can be 3 away from 2 and 8. 8 can be 3 away from 5, and 9 can be 3 away from 6. This can't be 8, though, because of 8 in the box. This sees only 3 cells. That's interesting. That are shaded. Obviously could go that way, and that would be fine. Remaining digits in row 3. We have 1, 4, 5, 7, 8, and 9. This can't be 8 because of 8 in the column. No 4 here because of 4 in the column. This cannot be 7 anymore because these have to be 4 difference, and 7 cannot have a 3 here anymore. So it's either 4 and 8 or 5 and 9, which are 4 away from each other. This can't be 1 because of 1 in the box. This can't be 1 because of 1 in the column. Well. Can this be 5 shaded? That's interesting. So if this is 5 shaded, then this has to be unshaded because of the 2 by 2 area. You cannot connect here, so then this would be unshaded also. This has to see 5 cells, so this sees So this can never be seeing 6 cells. Because if we go 6 here and here, this sees 1, 2, 3, 4, 5, 6. So this cannot be shaded, which means this is unshaded. So it must go out that way. How many cells can this be then? 1, 2, 3, 4, 5 at most. Because these would then connect. So this is 3 or 4 here. And they add up to 3 or 4. If this is 3, then this has to be 1, 2 as a pair here, which could be the case. If this is 4, this is 1, and then that's 3, which doesn't work. So this must be 3. So this has to be 3 here, which means this is 1 or 2, and this is 1 or 2. Which eliminates 1 and 2 in the rest of the column, and box. This can't be 3 anymore. Where's 3 in box 1? It has to be here. So that's 3. Can this go 5 down here? No. It can go only 4, so this must be green. Blue has to go out here to be orthogonally connected to the rest of the blues. This blue, if this can't go 4 here, so it has to go green here, which means this blue must connect orthogonally to this blue. So it could connect that way, potentially. Or it could connect that way. This sees 3 cells. It must orthogonally connect. This can't connect again with these because then that would be a region with 2 circles. Same here. So that's why this has to go 4 that way. This sees 3 cells, so this is blue. Therefore, this is green there. This must orthogonally connect. But you could have 6 going all the way up to here. So this has to orthogonally connect. So therefore, can it orthogonally connect this way? I think the answer to that is no, right? Then it has to orthogonally... Green has to go... So if this goes this way, the problem is this can't be size 6. Right? This is shaded because if a pairrow is unshaded, they would have to sum to 1 or 2, which is obviously not going to work. Oh, wait, you could have this be green. This could actually be green because you could have 1 and 1. I didn't think about that. Oh, no, this can't be 1. Okay, so no. And then this has to be shaded. Okay, well, there we go. So if this goes blue, blue here, it has to orthogonally connect, and this is only size 5 at most because you can't have a circle there. So it cannot go blue, blue there. It has to go blue, blue that way. And we don't know if this is blue or that's blue. It has to go one of them. Again, this could go up to 6 this way. This has to orthogonally connect. So it has to be at least 6 here, which means this is going blue that way. So these have to be green because this is size 6 as a region. And either this is green or that's green or this is blue and blue. Depends if this is a green here, right? It doesn't have to be necessarily. How does this work? Five away, and they must add up to 5. So this is 1 and 4, which means this can't be 1. That's 2 and 1 there. So no 4 or 3 here. This is 1, which must add up with 2 to add up to 3. That eliminates 2 in the rest of the column. So no 2 here. This can't be 1 or 4. These can't be 1 or 4, so 1 has to be one of these two. 2 eliminates 2 here. So this is 5, 6, or 7 away. Okay. Remaining digits of box 8, we have 1, 5, 6, 7, 8, 9. Obviously, 1 cannot be any of these, or 5. We have a contradiction. This cannot be 4. Oh. What was the bad assumption I made? I made some bad assumption. I don't know which one, though. Shoot. Oh, this can't see 6 cells this way. Well, it could be, if these are all blue. That's possible. So that would force us to be 6 there. But we have a problem, because 4 can't be here, 4 can't be here, 4 can't be... Why can't this be 4? Oh, they have to have a difference of 1 between these. Ooh. Not good. Not good at all. I might have to start from the beginning, because I don't know where I messed up. That's the thing. AQJHS has a lot of really cool puzzles, but they're very hard to execute on. There's a lot of stuff that goes through them. Ugh. Okay, I'm gonna have to do this again. Okay. 1 through 3. 1 or 2. This is 1 or 2. This is 1 or 2. That means this must be 3 away. This must be 4 away. Oh, maybe it was an assumption that one of these had to be blue? Maybe. That could be the case. Well, no, because this... 2 digits can never add up to 1. So this is always blue. And... well, it could be shaded here, unshaded. You could have 2 adding up with 1 and 1. That is actually... but, okay, no, this can't be 1 or 2. Because of the 1-2 pair in the box. So because of that, this cannot be the sum of these 2 digits. So therefore, it has to be 2 away. And it has to be a difference. So this is 2. Yeah, 1 can never be in a circle. Well, I mean, technically you could have green. And then this would be blue, 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 blue. But the problem is, in an arrow with 1 green... so 1 can never be in a circle that is shaded. Because then it would only see... it can only see itself, but it must be orthogonally connected to the rest of the shaded cells. If we have 1 as unshaded, that could work, but then these would have to add up to 1, which is impossible. So 1 can never be... okay, 1 can never be in a unshaded pairrow. It has to be either in shaded pairrow... right, 1 can only be in a shaded pairrow. But 1 can't be in a shaded circle, because it only that's saying it only sees itself when it must be orthogonally connected to the rest of the shaded regions. So because of that, if this is 1, it's unshaded. But then 1 can never be an unshaded circle. So this can't be 1 either way. So this is 2. This is 1. 2 could be green if this were both 1, but that we can't have a 1 in this box. So this must be blue. So this only sees 2 shaded cells. 1, as a pairrow, can never be unshaded. So this must be blue, which means these are all green. So that's correct. This is 1, which makes this 2. This cannot be the sum of 2 digits because they're in the same column. So this is blue. This is the green. So again, 1 cannot be an unshaded cell because the sum of digits can never add up to 1 with 2 digits. So then this has to be 3, 4, or 5 here. This also could be, this has to be, so this is 3 away, and they add up to 3. So this has to be a 1, 2 pair. So we have 1, 2 as a pair. This cannot be green because they would be orthogonally connected, and you would have 2 circles there. It can't be orthogonally connected here, so this can't be green. That's blue. This is 1, 2 as a pair, which means this cannot be 1 or 2 here. So this is at least 3 away, and it has to be 3 away because this can only go 3 that way. So this is 3 here, which means this can't be 3. The sum of these would be at least, this is at least 5, so this can't be a sum. This must be blue. This is at least 6 away. It could be 1 away. Wait, if it's 1, again, it has to be green in that case, which is impossible. So this is 4, 5, or 6 here. This can be up to 1, 2, 3, 4, 5, 6 away. So this is 4, 5, or 6. Cannot be 1. This can't be 1 because it's green. We have 4, 5, 6 as a triplet in column 3. Right? This can only go up to 6 away. Cannot be 1, 2, or 3. This can go 5 away or 4 away. Up to 5 away. This can go up to 6 away. But the thing is, the problem is that this can't be, this is going here or here. You cannot have, so therefore it's, if this is green, it would orthogonally connect to that. So this can't be green. This is blue. This can go up to 5 this way. And it cannot be 1, 2, or 3. So this is also 4 or 5. Interesting. This can't be 1, 2, 3, 4, 5. So we have 6 through 9 here, 6 through 9 there. Remaining digits of column, because of the 4, 5, 6 triplet in column 3, have to be 1, 7, 8, 9, right? This can't be 1 because of 1 in the box. These have to have a difference of 1. So it could be 5 through 9 here, and this is 6 through 9 there. 4 away. Maybe it was this disqualification. I don't know where how I removed that 1 there. Maybe that was the issue. If this is blue, this again has to be green. The problem with this is, so this can't connect to blue here. If this is blue, then this would see at least 6 cells. So, if this is blue, this must be green here. The problem is this has to see at least 6 cells. So it sees 1, 2, 3, 4, 5, 6, but then this also sees 6 cells if this is blue. So this can never be blue. This is green, which means green has to go out that way. This is 3 and it's green, so then this is the extent of that. So these are all blue. If this is 4, adding up to 4, it must be 1 and 3 there. If this is 5, this must be 1 and 4 there. So one of these is definitely 1, which means this can't be 1. This, what's the largest this can be? It can be 1, 2, 3, 4, 5. And then it cannot go here, so this is 3, 4, 5 here. If, again, this is blue, this doesn't have a green circle to be part of, so they would both have to be blue, and this would all be blue. So therefore, this is green. I think it was this assumption here that was a mistake. Anyways. This sees at least 4. Remaining digits of row 7 are 5 through 9. Remaining digits of row 4 are 4 through 9. No 4 here because of 4 in the column. This sees 1, 2, or 3 away, so this is 1 or 3. This can go up to 6 away. So either this is 1 and this is 3 adding up to 4. Right, 4 away here, 4 away here. Or it's 5 away and this is 1 and this is 4 adding up to... So this can never be 4. If this is 4, that would eliminate that possibility. Can you ever have a 1 here? Again, 1 in a pairrow has to be has to be shaded. But 1 in a circle has to be unshaded. Because you can't have 2 digits. You can't have 1 be in a shaded cell which only sees 1 cell. So this can't be 1, this is 3, which means this can't be 3 here. That seems fine. This is as a difference of 4, 5, or 6. So 4 could certainly have a difference of 4, 5, and 6 there. 5 could certainly have a 3. That would be 3 and 8 in that instance. 6 would force this to be 4 or 5. This can't be 6. 1, 2, 3, 4, 5, 6. A difference of 4 and 6 is 10. Difference of 5 and 6 is 11. Or 4 and 6 is -2. 5 and 6 is -1. So this can't be 6, which means this has to be 6 here. Yeah, and I think this was the bad assumption here, right? Okay. 6 in here. That means you cannot have a difference of 6 in 4 and 5 because of what we just said. So this must be 6, which makes this a sum. So this is green. And this must be 1 or 2. Okay. This adds up to 3. So this is essentially done. This is not necessarily done. Difference of 2. So difference of 2 and 4 could be 2 or 6. 5 could be 3 or 7. Okay, difference of 1. This is essentially done. So this one's done. This one's not really done. Neither is that pairrow. This is a sum. So it actually could be 5 here. So, yeah, the reason why we had 3 here is because, well, this was, I don't know. This has to be 1, 2, 6, 7, 8, 9. Oh, this must see 6 cells. This cannot go this way or this way. Right? Because, so it's 3 at least, which means this is, or, yeah, green. Therefore, this sees at most 6 cells, so it has to go these 6. So this is 6. Obviously, none of these can be 6. This can't be 6. This is blue. 2 by 2, that's all blue, so this must be green. It has to orthogonally connect to here, so that's green. This must go green there. Blue has to go there. Green has to go here. Blue has to orthogonally connect. So that's blue. So 4 here. And this is 5 at most. Blue has to orthogonally connect. Again, we have the same problem. But, okay, so this 1 and 2. Well, we don't know what this is. Green has to go here to make sure it's fully as a region. This is 3, that's fine. This is 3, cannot be 5 now. So it's 3 or 4, because this sees 6. Yeah, I don't know how I eliminated this possibility. Maybe, yeah, it was probably the ones there that was confusing me. I think that was what was messing me up. Okay. 3 away. Oh, it has to be 3 away. That's why it can't be 1. Oh, so I'm still getting the same thing. 3 away from that can't be 1. So this has to be 1 here. So this is 4, that's 5. Shoot. Which means these can't be 5. 4 eliminates 4 here, so that's 5. Not 4, 5. So it has to go there. How did I say this was 3? Maybe that was the error. Okay, so no 5 here. No 5 here. 5 away. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5 is 8. So no 8 here, no 8 here, no 8 here. 4 away is 1 and 3. Difference of these 3 and these 3. 7 cannot be with any of those digits here, so this can't be 7. It's 8 or 9. 3 away from that is 5 or 6. Yeah, so maybe the issue was this being 3. Huh. 3 can't be here, 3 can't be here. Remaining digits of column 2 are 3, 4, 7, 8, 9. 3, 4, 7, 8, 9. No 3 here, obviously. This is 5, so that's done as a region, so this is blue. Can you get these adding 3 adding up to 3? And the answer is no, because that would eliminate all possible. This is 5. This is 1, right? Because 1, 2, 3, 4, 5, 6 away. 1, 2, 3, 4, 5, 6 away must add up to 6. So you can't have 1 and 2 adding up here. So therefore, this is blue. This has to see 3 because it's 3 there. Therefore, this is green there. This must orthogonally connect to blue. So it has to be blue there. Can this... This has to be all green. Because blue has to orthogonally connect. It cannot connect to another circle. So this must be all green, which makes this blue. So this has to be blue going that way to orthogonally connect. This must orthogonally connect also. This is blue. This has to be blue because this is only size 4. This is blue. So this sees 1, 2, 3 there. This is 5. It must orthogonally connect to the rest of blue. And this is 4, so this must be green here because it sees 4 cells. Yeah, I think I got this as 3, which is incorrect. I think that was the issue that I had. So this sees 3 cells, therefore this is green, this is green. This has to orthogonally connect this way. So this is size 8, but the blue, this green has to be part of a green. So it can't go here because that would block the blue in from being all orthogonally connected. So this green has to go this way, which means blue has to go all the way around and then connect. So that's 1, 2, 3, 4, 5. Yeah, I think the problem was I made this 3. I don't know how I made that 3. That's the crazy thing. Oh, because this is, if this is 4, oh, you could have 2 and 2. That's the reasoning. Okay, that was the problem that I messed up on. You could have 4, 2, and 2. I see. So I assumed it had to be 3, which is incorrect. Okay. That makes sense, then. So I guess well, let's continue. 6 is done. So this is done. That's 1 and 5. 4 is done. That's 1 and 3. This has a difference of 4. We don't really have that yet. This has a difference of... This adds up to 3. That's done. Difference of 2. So 5, it has to be 3 and 7 here. But that's not helpful. Difference of 1 cannot be 6, so we're guaranteed an 8 here. It's either 7 and 8 or 8 and 9. That eliminates 8 from the rest of the column. Remaining digits of box 1, we have 3, 4, 5, 7, 8, and 9. Obviously, no 3s there. How did I get a 4 here? I had a 4 here somehow. I don't know how. 3 difference. That's not helpful. 3 difference here. That's also not helpful. Oh, 5. 1, 2, 3, 4, 5. Ah, that's the reason why. So this must add up to 5. And we cannot be 2 and 3, so it must be 1 and 4. Aha. So this is 4, which eliminates 4 from being here or here. Whereas 4 in box 7, it has to be here. And that's the contradiction. So 4 away has to be, then this is 4 away here, 4 away here, add up to 4. You can't have 1 and 3, so it must be 2 and 2. Oh, we already had a 1 there anyways, but yeah. So that eliminates 2 from being there, and this is why it's not a contradictory. So that's good. So we have that. Okay, so then this is done. This has to be 3, 6, 7, 8, 9. This is 4 that it's in its island. So this is green, which means this sees 5, so this must be blue. This is a 2 by 2, it's all blue, so this must be green. And then this has to be the green it corresponds to, right? This is already 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be too many. So this must be part of that. So that's green. So we have 6 there. This is 3. That's 3. Remaining digits in box 7 or 8 are 1, 5, 6, 7, 8, 9. No 1 or 5 there. We have a 3, 6, 7, 8, 9 quadruplet, or quintuplet, which eliminates 3, 6, 7, 8, 9 in the rest of the box. So this is 2. This adds up to 5. So that's done. Also the circle. So this circle is done. This is 4. That's done as a circle. This is done as a circle and pairrow. Done as circle and pairrow. 3 away. This sees 3. So that's done as a pairrow, but not as a circle, but not a pairrow. Same with that. 3 away. So kind of done. I guess we'll make those pink. Done as a circle, but not a pairrow. This must be a sum. And it can be up to 7? Yeah. So it's 3, 5, 6, or 7 there. Does 3 work? No, because this would be 3 away. So it cannot be 3. It's 5, 6, or 7. Remaining digits in this box are 3, 5, 6, 7, 8, 9. So 3 is one of the... This can't be 3. Where is 3 in the box? It has to be here. 5 away. 1, 2, 3, 4, 5 does not add up to 5 because that's a 6. So it's 6 or 7 away. 6 away has to be, so 1, 2, 3, 4, 5, 6 would mean that's 4 plus 2, but 2 can't be here because 2 in the column. So this is 7, which eliminates 7 in the rest of the row. That eliminates 7, 8, 9 here, 7, 8, 9 here, 7, 8, 9 here. No 7 in the box. Where's 7 in row 7? It must be here. So that's 7. This is 1, 5, 6 as a triplet, which eliminates 1, 5, 6 in the rest of the box. So this is 7, 8, 9 as a triplet. That eliminates 7, 8, 9 in the rest of the row. So this is 3. No 7, 8, 9 or 3 here. It's 6. No 7 here because of 7 in the column. No 7. No 4 here. No 3 here. Where's 3 in this box? It must be there. 7 away is then 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7 away. 1, 2, 3, 4, 5, 6, 7, right? So these add up to 7, so this must be 4. So 3 and 4 there, which eliminates 4 from being here. We have 5, 8, 9 as a triplet, which eliminates 5, 8, 9 in the rest of the box. So this can't be 9. That's 7. This can't be 7 or 9. It's 4. That eliminates 7 from being here. These are definitely 8 and 9. That's 1 apart from each other. So that's done. Okay. So let's look at the continued pairrows. So this is done. Pairrow this. 5 and 8, that's done. And it sees 5, so that's all done. It's a circle. Column 1, column 2 pairrow. This is not done. 6 is done. It has 6 in its region. That's done. 3 it sees. And 3 away. It's kind of done. Pinkish. 4 sees 4. 4 away. So if this is 5, this would have to be 9 because it cannot be 1. If this is 8, this has to be 4. Cannot be 4 there. So this can't be 8. 9 means this has to be 5. So this is a 5-9 pair in row 3, which eliminates 5 and 9 in the rest of the row. That leaves the remaining digits as 1, 4, 7, 8. No 1 or 4 here because of 1, 4 in the column. No 4, 7, 8 here. So that leaves a 1 there, which means this can't be 1 here. No 4 here. Where's 4 in row 3? It has to be here. So that's 4, which means this can't be 4. These are 3 away. So 5 can be with 2 or 8 here. Cannot be 8 because of 8 in the box. 9 can be with 6 here. So this is 2 or 6. 4 away is kind of done. Yeah, this is actually done. So this is red. The blue has to orthogonally connect to the rest of the blues. So this has to go blue there. Wait, but that sees 5. Oh, wait, it can't go blue here. This is 5, so this is green here. So then this must go blue there. Okay. That's fine. One of these is green. We don't know which. Could be both, actually. This is size 7. This cannot go green, green here. We have 5 so far. It cannot cut off both blues from connecting. Right, because this is an island here, island here. This is orthogonally connected. It has to orthogonally connect to the rest. So cannot be green, green here, which means it's at best green, green here. And then it has to go green there. So this is guaranteed to be green. It cannot cut off that green. This is blue then. This must go blue here. It cannot be part of this region. So then this has to go blue all the way around here. This is green to see size 8. 1, 2, 3, 4, 5, 6, 7, 8. So now this is done. I should basically not color them red, though. Remove the red. It's harder to see. Oops. This is green. So let's just mark them as done with circles. So 8's done. 5 is done in both senses. 3 is kind of done. So we have the pink-ish. So I guess we can mark 6 is... Okay, so let's continue. Okay, so let's remove the pinks. So 3 is done as a circle. Same here, but it's not done as a pairrow. 5 is done. 4 is done as a circle and a pairrow. So that's fine. 3 is done as a circle and a pairrow. 4 is essentially done as a circle and a pairrow. 5 here is done as a circle and a pairrow. 4 is done as a circle and a pairrow. That was the one that was painful, which I messed up. 2 is essentially done as a circle and a pairrow. 1 is done as a pairrow. 6 is done as a circle. 6 is done as a circle and a pairrow. 7 is done as a circle. So this is 1, 2, 3. Okay, this must connect that way. 1, 2, 3, 4, 5. We have 6, 7 left. And if it has to be green, green. Because if we try to go green, green, that's blue there or blue there. If this is green, that means this one of these is blue and it's not orthogonally connected. So this must be blue and this is green, green. So this is done as a pairrow and a circle. Okay. We just have pairrows for these, and then pairrow for this. Okay. Let's continue. So 2 away. Remaining digits in column 4. We have 1, 2, 5, 6, 7, 8, 9. No 1 here, no 7 here. No 6 here. So 2 away cannot be either of these. 2 away and 1 away cannot be here either, because 1 and 2 can only be next to 4, can be with 4, and 1 can only be with 3. So this can't be 1 or 2. 5 can only be with 7, so this can't be 5 here. 7 can be with 5 or 9. 8 can be with 6. This can't be 8 then. 9 can be with only 7. So this can't be 9 here. Okay. So that's kind of done there. This is 3 away from each other. So 5 forces that to be 2. 9 forces that to be 6. So I guess this is kind of done. 3 away. So you have 3 away here and 3 away here. What digits can this be? 2, 5, 6, 7, 9. 3 away can be 2 and 5. So 2 can make that 5. 5 can make that 2. 6 away can be with 9. 9 and 6. 7 cannot be 3 away from anything because they can't be 4. So no 7 here, no 7 here. This could be 8. So this is kind of done also. 4 away is done. It's 5 and 9. Okay. And this is either... Okay, so cannot be 2 away because 4 and 4 are not going to be 2 away. So this must be 1 away. Which means this can't be 1. We have 5, 6 as a pair in column 6 and box 8. Which eliminates 5 and 6 in the rest of the box. So this is 1. That means this can't be 1 here. 5, 6 eliminates 5, 6 in the rest of the column. So this can't be 6. Remaining digits in column 6 are 2, 4, 7, 8, 9. This can't be 4 because of 4 in the row. No 4 here because of 4 in the row. We also have a 1 missing in box 5. And it cannot be here or here or here. And this can't be 1 because of the difference between the 5. So this must be 1 here, which eliminates 1 here. So this is 1 here. Where's 3 in box 5? Can't be here, here, or here, so 3 has to be here. That's a difference of 3 and 5, which works. 4 is one of these 2. 2 is one of these 3. Difference of 1 here. The remaining digits in row 1 have to be 2, 5, 6, 8, 9. And this digit has to be 5, 6, 7, 8, 9. 2 is not going to be here because this does not have a difference of 1 with this digit. Remaining digits of column 7 are 2, 5, 6, 7, 8, 9. No 8 here because of 8 in the box. So this is kind of done, I guess. 2 eliminates 2 here. So where's 2 in box 2? It must be one of these 2 digits here. Where's 2 in box column row 1? It has to be here, so that makes this not 2, it's 6. So 3 away from 6 is 9. So that's 9. This is 5. No 5 here. No 9 here. No 9 here. So this is definitely valid. 3 away from this. This cannot be 6. If this is 2, that's 5. If this is 5, that's 2 or 8. If this is 9, that's 6. This cannot be 9 here. What about this? Not quite done. This 9 eliminates 9 in the rest of the box. Remaining digits in this box are 5, 6, 7, 8. No 6 here, no 7, 8 here. 6 eliminates 6 here, and 6 here. We have 4, 5, 7, 8 remaining in column 9. 8 cannot be here. Okay. All the circles and pairrows are accounted for. 3. Well, still working on that. That's done. This is 3. 2. Remaining digits of column 8. We have 3, 5, 6, and 9. And this can't be 3, so we know this has to be 3 there. 6 eliminates 6 in the rest of the row. Row 6. This is 8, 9 as a pair, which eliminates 8, 9 in the rest of the row. So, and the box, so this can't be 8 or 9. It's 7, which makes this 8. There's no 8 here, or 7. No 7 here. 6 eliminates 6 here. If this is 9, that makes this 6. 5, 6. Okay, so let's mark these. This is still kind of hairy. So we have A, B. This is, okay, remove these. So A, B makes this A, B, A, and B. B cannot be any of these. So B has to be one of these 4. We'll mark that with B and Z. Let's B and Y. That makes this Z, which makes this Y. So Y is one of these 2. Oh, where's 5? Right, where's 5 in box 5? Cannot be here or here, so this must be 5 here. That eliminates 5 in the rest of the column. 8 eliminates 8 here. 8 eliminates 8 here. Where is 8 then? Where is the remaining digit? This has to be 2. That's 2. The remaining 2 has to be here. So this can't be 2 here. This is 8. 2 away from 8 is 6. So this is 6 there, which means this can't be 6 here. Where is 6 in box 5 then? Can't be here because of the 5, 6 pair. Can't be here because of the 6, so it must be here. That eliminates 6 from being here, here, or here. We have 5 or 8. 5, 7, or 8 here as a triplet, which eliminates 5, 7, 8 in the rest of the box. So this is 6. No 6 here. So this is done. 2 away. 3 away, still not quite done. 3 away from 2 is 5, which makes this 9, that's 4. That makes that 7 and 2, which makes this 7. No 4 and 9 here, so that's 2. No 7 here, so that's 9, which makes this 4. So now this is done. Oops. No 7 here, no 7 here. So this is B, which makes this A. Interesting. B has to be one of those 2. 5 eliminates 5 here. So this is 8, which means B's have to be 9s. So B's are 9. A has to be 8. So no 8 or 9 here, it's 5. No 5, 8, or 9 here, it's 7, which makes this 5. 8 eliminates 8 here, so it's 7, which makes this 8. This can't be 7 or 8, it's 9, which makes that 7. This is 3 away from 9, so y must be 6. So that leaves this z as 5. This can't be 5, it has to be 8, no 9, so that's 5 here, which makes this a 9. Whew. Yeah, so I had a bad assumption there. So that was not good. Quite a doozy. Yeah, I mean, it's hard. I don't think I would classify it as very hard, though. I agree with the raiders at Logic Masters Germany. If I hadn't made the mistake here, it would have been pretty straightforward going down the path. So yeah, everything else I had logicked out pretty well. Just this one. I forgot that this could be 2 and 2. Which is actually sometimes a bad assumption I do make occasionally there. So that was a pretty bad assumption. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.